So, and having said this, I want to announce the next speaker, who will be Christian Cajochen. Probably I misspelled, sorry for that. He will from Switzerland, Basel, and he will talk about the bright and dark sides of light, how it influences our circadian health.
Good morning, everyone. Thank you very much, Professor Reiser, for inviting me. And I told you I'm not a hypertension person. So I'm a chronobiologist working at the psychiatric hospital in Switzerland in Basel, and we use light. We use the non-visual effects of light to treat patients, mostly with depression. So I just going to try to give you an introduction why I don't have any conflict of interests, and start just right into the topic. I would like to start with the dark side of light, and as you know, there is a lot of light going on during the night, so Europe, and not only Europe, gets brighter. And if you look at the Polish map here, even here in Krakow, we have quite a bit of light during the night, which is, of course, we need that because otherwise we could not drive our car home, or we cannot walk home, or we cannot go out for dinner. So we need artificial light at night. But what does it do to our sleep-wake cycle? And I'm a sleep researcher as well. So there was a huge study in the US looking at almost 20,000 people, linking the outdoor light pollution with sleep-wake behavior. And you can clearly see now in this slide here, the more outdoor light, the brighter the light was, the shorter the sleep length on the right-hand side panel, the later the bedtime, and the later the rise time. So it makes you sleep shorter, and it makes you more of a kind of a late chronotype, because light can shift your circadian rhythms, and if you have too much light, especially in the evening or at night, it can shift your circadian rhythms. This was still significant when controlling for different factors which are listed here. And there is another thing. Every one of us has a smartphone, and if you look at the smartphone is your new bedroom partner, and if you look at a survey in Germany and also in China, for instance, the last thing you look at is at your light source, which is your handy, and every one of us has it in the bedroom because we think it's important. And when you ask young people, especially young people, they still respond to chats or to calls during the night. So there is also light pollution in your bedroom. Is this significant? Yes. There is also there is a study by a colleague in Australia. They actually looked what kind of light levels do they have in the evening before they go to sleep. And you can see here the distribution. This is in melanopic illuminance. Melanopic illuminance is the new SE unit to quantify the biological effects of light. We call it the non-image forming, the non-visual effects of light. And you can see most of us have around 10 to 20, which is not too much. And we don't have the incandescent lamp again, but the authors actually concluded that we found nearly half of homes had bright enough light to suppress melatonin. You know, melatonin is a hormone secreted during the dark phase by 50%. And they also found an association between greater evening light exposure and more wakefulness after bedtime. So clearly a negative effect on your sleep. So why do I emphasize these non-image forming effects of light? I'm sure you know this. There has been this huge, important discovery for chronobiologists 20 years ago that besides the rods and the cones in your retina, you are looking at the retina, I don't have to explain this to you, there is this new photoreceptor class called IPRCGs. So these are intrinsically photosensitive retinal ganglion cells. And ophthalmologists, they didn't know about it. But why is this important? Because they catch the light for these non-image forming effects of light. And there is a highway straight to the SCN. That's the main route, the suprachiasmatic nucleus, which is the central circadian pacemaker, which drives all our circadian rhythmicity. So that's the highway there, and you can be circadian blind, and you can also be visually blind. So we have sighted patients who are not entrained to their 24-hour rhythms. They can perfectly see, but they are time blind, so to speak. And not only the SCN is important, so there are very nice and very important sleep regulatory regions, the lateral hypothalamus, the Wilpo, and there are also the amygdala. I'm not going to go into that, which is important for mood regulation. So that's why light is just more than vision. And we sometimes underestimate it. I just want to show you a small result by Isabel Schöllhorn, a former PhD student, because she was able to develop a light source which can specifically target these intrinsically melanopsin photosensitive ganglion cells. So she was an engineer in my lab, and she was asking the question, are low light levels, which we usually experience in the evening, important for our sleep and circadian physiology? And you can see the light intensities she chose was corresponding to a dim light condition, a light condition you usually have when you look at your cellular phone, iPad, or computer screen. And she had a high melanopic in blue and a low melanopic in orange. And everyone went through these conditions. And our primary endpoint was sleep latency. So how long does it take people to fall asleep, measured by the EEG? So it was a PSG recording. And you can see in the blue columns, they're always higher. So when they received the high melanopic light, and they couldn't differentiate because it was just a white light source. It was not orange or blue. It took them to fall asleep later. So you can see it's 10 minutes. It's not a huge difference, but these are very good, healthy sleepers, and it increased a little bit with the intensity. And she found a very nice dose relationship between the melanopic content of your screen light and the duration to fall asleep. This is sleep latency. And also when she looked at melatonin suppression, the more melanopic light you have in the evening, the more you suppress melatonin, and your melatonin phase is going to be delayed. So the question was answered, yes, indeed, we are very sensitive to light in the evening, and we are very sensitive to high melanopic light in the evening. So if you had like a tuner on your screen where you can tune the melanopic content of your screen, it would be nice without changing the color temperature. Now, I don't have too much time, so I would shift now to the bright side of light, because I talked to you about the negative effects in the evening. And as you know, we have developed over many years now, and artificial light was only invented 150 years ago, 120 years ago. So our evolution is actually adapted to high daytime lamps. Even now we are inside, and we spend more than 22 hours inside rooms, which is, from a chronobiological point of view, darkness. So we are now sitting in your darkness. This is not really good for our circadian rhythmicity, because the side gable light is missing right now. And this is an example, an extreme example. I always show this is a nursing home in California, in sunny California, 2:20 in the afternoon, and you can see these older people are sitting around in darkness, 20 lux. And below you can see a rest activity cycle in such a patient. So this is timed. These are like four days, and you see during darkness the patient is supposed to sleep, but there's a lot of activity during the nights, and there is less activity during the day. And then my colleague, not in California but in Holland, Eus van Sommeren, he just put in light in those elderly homes, 10,000 lux or 1,000 lux, and you can see the same patient below here, a very more robust circadian profile in activity. And also the nurses actually appreciated a very simple treatment. Just put in light in the elderly homes during the day, and you can probably see improved circadian rest activity cycles. The same was true a study we did in Zurich, where we looked at sleep and melatonin secretion in patients with severe dementia. They couldn't answer any questionnaires any longer, but you can see that when we exposed them to more light, so in the highlight group, a rated pleasure and general alertness was improved, and also quality of life was better in those patients. I can show you many, many examples, but I don't have to. That's another study by a colleague at Stanford, where she actually looked at the association between daytime light exposure and sleep-wake fragmentation. You can see here that if you have more daylight, your sleep is less fragmented. And last but not least, but I like this because it's a classical study from Japan, from my colleague Mishima. He exposed people to midday light for 4 weeks, 10,000 lux, and you can see melatonin secretion during the night. So if you give light during the day, you can increase your melatonin secretion during the night. When you give it during the during the night. When you give light during the night, of course, you have to expose. But what's interesting here, he also could see that this increase in melatonin secretion led to an amelioration in sleep. So they had less awakenings during sleep. There was a very nice correlation between the increase in amplitude and better sleep in those studies. Of course, these are not epidemiological studies. I'm not an epidemiologist, but just want to show you, we also go out into the field, and this was during COVID. Air traffic controllers, they complained about really bad light. On the left-hand side, you can see September 22. We had the opportunity to completely refurbish this room with a light designer. On the right-hand side, you can see it looks, in my view, much better. The one on the left side is more like from the 70s, and the after one was just more modern. So we increased the light levels during the day quite a bit, above the recommendations. We also increased color temperatures to 5,700 Kelvin, so it's a more bluish light, and we distributed the light all over the place on the ceiling. And during the night, we considerably reduced the light during the night shifts to 3,000 Kelvin and very low light levels. And then we wanted to measure sleep and melatonin. But you know, people from Sky Guide, they say, well, we are just happy with it. We don't need a study, which was really disappointing for us. So we could only do a survey. And we did it 1 year later. And you can see that people perceive the light as being more natural. They feel the brightness to being more agreeable. And I don't have time any longer, sorry. Okay, I'm going to stop now. They feel more lively. And so the recommendations now: go as low as possible during the night, go as high as possible during the day, use more blue portions during the light, during the day, and not so during the night. And just to come back to epidemiology, there is some very new data, or not very new data, but recent data showing that, yes, indeed, day and night light exposure are associated with, for instance, psychiatric illnesses. These are biobank data in people from more than 85,000 people. And you can see the more light at night, the higher the risk for developing, this is just major depression. If they had more light during the day, there was less of an increase or a decrease in MDD prevalence. There's another study, brighter night at dark days predict higher mortality risk. And they actually measured light levels on light loggers in more than 89,000 people over 40. And here you can see cardiometabolic risk, for instance. So if you have light 4 o'clock in the morning, problem is, why do they have light 4 o'clock in the morning? But you can see the cardiometabolic risk is significantly higher for the 90th to the 100 percentiles here in the middle for the cardiometabolic, and then it disappears when you go down in the percentiles. And last but not least, of course, for you the question is outdoor light at night and hypertension. And I said I'm not the expert, so I needed consensus to give me an overview. I'm not sure whether you know consensus, but it's quite a good tool right now. I'm just still testing it. And it looks like that, yes, there is epidemiological evidence that higher light at night leads to a hypertension odds of up to 1.31. There is a nonlinear dose response in these papers, and also meta-analysis confirmed this. And the mechanistic insight is, of course, why? Does it go via sleep? Does it go via disruption of circadian rhythms? I think it's not really clear. Or is it like a direct effect on the autonomic balance during sleep? There are some strong associations. So it looks like that females and short sleepers are at higher risk, and genetic factors have also been found. Older adults, physically inactive, urban dwellers, and low green space seem to be more vulnerable, but we have to be careful because there are some limitations. As I said before, some studies didn't take in the SES and sleep duration, so it could be mediated by a change in sleep behavior, and there are some small groups which did not find it. And with that, I would like to thank my group in Basel. So sometimes you are also going to the daylight, and you for your attention. Thank you very much.